Hi, I'm Jeremy Howard from Answer AI, and I'm joined here by Sarah. Sarah is Answer AI's first ever fellow, first founding member of our fellowship program. And today we're going to hear a bit about Sarah's background and experiences. I think you'll find her a really inspiring and amazing human being. So thanks for joining us, Sarah.
Thank you for having me.
So let me just rewind a little bit for those who haven't had the pleasure, like I have, of getting to know you and who you are. Sarah is a person who has a remarkable achievement of getting published in NeurIPS, the world's premier academic AI conference, whilst still at high school. Um, and I met Sarah at NeurIPS. The paper she published is extremely high quality work and extremely interesting. Um, and I was thrilled to discover that her background included learning from my courses, from Fast AI courses, and we stayed in touch. Everything I saw Sarah do was incredibly impressive, and so I wanted more than anything else to find an opportunity to work with her. So we offered her this role as a Answer AI fellow. So, Sarah, maybe to start with, could you summarize for a somewhat layperson audience, like the research that you were presenting at NeurIPS? What was the purpose of the work, of the research you were doing, and what did you find?
Sure. I started this project, I think, towards the beginning of 2023. At that time, ChatGPT was still like relatively, or I think, yeah, relatively young. And we were interested in doing this thing with multi-step reasoning. So at the time, like these large language models really struggled with producing coherent and correct mathematical reasoning and logic. And so we were interested in finding ways to improve that. So one of the papers that we kind of based our approach off of was from OpenAI. They used these reward models as verifiers to kind of verify whether these steps in a multi-step reasoning process would be correct or incorrect. And what was interesting about their approach was that instead of having one reward model that would produce a single reward, kind of telling you whether the solution was correct or incorrect or somewhat of a mix between the two, this would basically grade each step. So it would tell you where exactly the response went wrong. And yeah, it would give you kind of a more specific kind of feedback in terms of that.
And
And so,
let's
yeah,
talk about our let's talk about OpenAI for a moment then before coming back to how you built on this, because this is very much in the news now. So OpenAI recently released a pair of new models called O1 Preview and O1 Mini, which are dramatically better at reasoning than previous models. And they seem to be taking advantage of a training system that uses this kind of approach. OpenAI have explained how they've been explicitly taught how to, or being given feedback on their reasoning steps and have learned to become better reasoners as a result. So it's interesting that it seems you, you picked a problem which I think not coincidentally has turned out to be really important in practice.
right. And so kind of more on that the actual origins of our project weren't on mathematical reasoning. Originally, we had been looking at sort of bias in models in terms of the more like kind of like ethical implications. And we realized that a lot of times like statements were not logically connected with each other. And so this kind of led us down the route of logical reasoning. But yeah, that was kind of a tangent, but back to the
Well, how did you
actual.
build on top of then that OpenAI work? Did you take it in a different direction, or you kind of took it a little further in the same direction, or what?
Well, I mean, the PRM paper. Yeah. So basically what we did was they basically only trained their verifiers. Um, they showed that the more process reasoning oriented ones were better than the objective sort of holistic ones. And so we decided to take it one step further and actually use it in an RLHF pipeline to update a sort of like uh, completion model. And
So
so
I know this is
uh,
a second nature to you, so let's just rewind a bit. So RLHF is reinforcement learning from human feedback. So this is the third step in the process that OpenAI used to build stuff like the ChatGPT model, where they get human beings to give feedback about different possible answers to a question, and it helps the model learn better what human beings are looking for.
Right. So typically a human is given two model responses. The human rates it, um, or picks the better one out of the two, and then based on that preference data, like a reward model is trained. But for us, there was a data set released by OpenAI that had that like process feedback where individual steps were rated incorrect or correct by human graders, and we trained a reward model based off of that. And so in terms of like the actual RLHF pipeline, there were a few key changes that we had to make just because the setup of our, I guess, process was a little different. I can talk on those a little bit more, but I don't know if you have any more like conceptual questions or any
Oh,
clarifications.
that's okay. So I just wanted to kind of, I think it helps to start, with like what you've been working on recently. So basically, it's taking a really kind of classic branch of research that turned out to be of great practical import, which is moving from just like, is this a good answer or not, to is this a good series of steps to get to an answer or not? And then building on that to then say, okay, with that, we can then hopefully come up with a model which can actually create the correct steps. And as a result, doesn't have to jump straight to the answer straight away. And yeah, and TLDR, your model had encouraging results. I mean, you weren't able to train it on the large amount of compute you would have liked, since high school researchers don't have access to OpenAI computers. Uh, but it looked good enough, at least, to get a NeurIPS paper. Um, so actually, I wanted to kind of then step back a bit to say, like, all right, I've through my work with Fast.ai, I would say like every year there's maybe a couple of high school students who I come across who do fast AI and become a extremely competent practitioner. Um, and so I've kind of got to know a few folks like you. And generally the experience is like a bit tricky because there aren't other people at school who have the same interests and capabilities, either teachers or students. Um, so, how did this work? How did this work for you? How did you get into artificial intelligence, and how did you then follow that interest, even though I assume you did not have a group of peers who were following that interest with you?
Yeah, you're definitely right about the peers thing. I think I started towards the end of middle school, beginning of high school.
So, what kind
My
of
brother.
age is that? For I don't know what middle school is in America.
Oh, okay. Yeah, I think I was like 13, 14 years
13.
old. Um, and so I had taken like an Algebra 1 course at like the highest math level, but my brother was taking the course because he's much older than me. He's, interested in this sort of thing. And so I was like, hey, let me, watch and let me follow along. And I think like the one thing that kind of carried me through the course, if you will, was actually like the kind of ease of like I don't know, just watching the lectures, playing around with the notebooks. It was
But for
something that
those who
was
haven't done it, I'll just explain there that like fast AI course is a bit unusual in that even though we do get to the point of like re-implementing recent research papers, we do it in this top-down way where you start out like building stuff basically. So it's and then you kind of only gradually get into the complexity of the underlying implementation as needed. So I guess you're saying that was like helpful for you as a teenager in working through it.
yes, very. I think I liked starting out with like the higher level ideas just because I got to see how they kind of worked. I feel like if you probably started with, I don't know, like back propagation or like any of those like, fancy calculus
That's
things, I
right,
probably
calculus.
but yeah, it was just nice being able to start out with like a bigger picture view of things. And that was definitely interesting. I had
Did you
no
and your
idea.
brother help each other? Were you kind of co-studying?
We kind of co-studied in like the very beginning. I think we watched like a lecture or two together. But as time progressed, like I realized that I didn't really like need him there next to me. Things were more or less
Yeah.
understandable. I think there was like a forum too. If I had any like questions, I could like go and
And you
like see
use
if
that?
someone else had similar issues. Hmm?
You used the forum?
I was mostly like a watcher,
Yeah.
like afar, kind of if anyone had similar questions, that would be super helpful. Um, wasn't too much of a poster myself, but it was very cool being able to see like a bunch of people kind of following along and doing their own thing. Like even if like my close friends weren't doing it, the only person I knew who was doing was my brother, who's like much older than me. It was nice like to think about having like that sort of like I don't know, there's just like a community of people online that are just really curious and driven
Well,
to learn. And
exactly. I remember a teenage girl from Bangladesh emailing me to say like, "Hey, I've just finished the Fast AI course. This seems really important and really good, but like all my friends think it's weird, and like I don't know anybody else that like really uses computers much. So like, is it okay? Am I doing something wrong?" And I was like, "No, you're better than okay. It's amazing, you know." And she went on to get a fellowship at Google and got flown out to Silicon Valley. And but you know, it can be yeah, it can be a bit weird until. And actually, I remember you telling me that going to NeurIPS was pretty important for you because suddenly you were surrounded by real life versions of these people and realized like, oh, it's not
yeah,
just you, right? That must have been
yeah,
amazing.
it was really cool. It was like one thing to like, I don't know, kind of just like see the presentations and talks and whatever, but like actually walking through like the poster halls and getting to like ask people about their research, like, wow, these people like are also interested in the same things and they like spend so much time doing or like asking the same questions that I'm interested in and things like
This is a
that. So it's
conference with
really
like, I don't
amazing.
know, 10,000 AI researchers or something all coming into New Orleans. And everywhere you go around the conference building, all the pubs
I
and
know.
restaurants are full of AI researchers.
Yeah, it's pretty insane.
I felt a bit the same way when I first went to San Francisco, you know, coming from Australia, where my interests were, I didn't really know anybody else who had them. And it was nice to suddenly find myself in a town with lots of other people who thought that what I was doing was interesting and they cared. Like it matters, you know. But you must have had a lot of tenacity because you were going for what, 4 or 5 years before you got to that point. I mean, that must have been a huge amount of work for you.
Yeah, I think like just like it was kind of my like side hustle. Like after school, I'd have, extra free time. This would be sort of my thing. I think part of it was also like AI was kind of getting, hot in the news. Is responsible for a ton of things, really cool papers, really cool breakthrough algorithms. And it felt like I was like in on something, because more or less like I could understand like what was going on. I think like there was like this headline I think about like AlphaFold and I was like wait like I know kind of more or less what's going on there and so that kind of helped but
So that was the
yes
protein folding model from Google, right?
yes and it had solved the protein folding problem as like the headlines kind of reported and so that kind of like helped me kind of stay interested stay driven and I guess it kind of just like blossomed once I like hit high school and I was in this program called MIT Primes that typically pairs students with like graduate students or professors, high school students with graduate students and professors to do this sort of like research project. And so for me, I was paired with Vlad Lealin, who was a PhD student at UMass Lowell, and now he's graduated with his
And
PhD.
he became your co-author on your NeurIPS paper.
Yes, who is my mentor and co-author, and basically taught me everything I need to know about AI research. But through that program, I was able to kind of take on like a new perspective because this entire time I'd been kind of like a student. I'd kind of like learned about these things, kind of played with them, kind of analyzed them from like the top down, picked apart their inner workings more or less. But now I was kind of presented with the question of like, so what? Like, what's next, right? And so,
Can I just
um,
rewind for a bit, like about the side hustle? Because like as a homeschooling dad, this kind of interests me because um, I think it might be somewhat more aligned with how I think about school education. Rather than spending more time doing your math homework, you were spending time doing something that's not in the curriculum. But if I'm thinking about it, I'm thinking, okay, you're you're doing fast AI. Lesson 4, you have to use the chain rule in calculus, which you would not have done in Algebra 1.
Yep.
So you must have been like, I don't know, what were you doing, like going to Khan Academy and stuff like that to kind of learn this stuff? And like, I imagine that then by the time you covered it in high school, it would have been reasonably straightforward for you because you've been applying it for years at that point.
Right. I realized like I'd taken multivariable at some point in high school and I was like, wait, like these concepts are very, very familiar to me. But I think like you're right in the sense that like for me, a lot of things were nonlinear. I think like in American schooling, especially, like there's a very, straightforward progression from
Right.
algebra one to, geometry to whatever to eventually calculus.
Yeah.
And I think like because I was just so interested in like AI, machine learning and things like that, I kind of just like took the initiative and learned the things that I needed to know. And so when it actually came time for math class, like a lot of things felt out of order just because they weren't.
Yeah,
Um,
and you would have been better at that math because you knew what was important, you knew what it was for. Like, as you know,
right,
my 8-year-old has recently started learning derivatives. And it's definitely not in her curriculum, but like we don't follow the curriculum because I
right.
figure like, yeah, if you do fun and interesting stuff, then it all comes around eventually. And, you know, yeah, I'm just trying to think like, what about like I mean coding even more so, right? Like in the US curriculum, I don't think there's much coding at high school generally, but in the Fast AI course, you would have had to have become reasonably proficient at Python to succeed there.
So I think I was lucky enough to have like a few Python classes at my middle school.
Nice.
But then again, very different ways of like thinking about programming. I think a lot of like introductory programming classes, I don't know, they're very like game centered. I feel like a lot of the
Oh,
like intro Python classes, you just like solve a puzzle and that's like the entire course.
yeah.
Um, but I think like what's helpful about I don't know, fast AI and maybe just like Python in general is that it's pretty readable. I think a lot of the notebooks for fast AI, they were on Colab, so I didn't have to worry about like t a terminal or like VS Code and things that were that, more
Yeah, you just click
complex.
a link and start
Go
typing.
button.
Yeah,
Exactly.
yeah,
So that was nice. And then also there were like a ton of resources online at that point. Even now, like, there's like ChatGPT, there's AI Magic. Like you can literally just, it's the barrier to access is definitely much lower nowadays. But it's just something that I had to learn on the fly. And thankfully there were enough resources to do so.
well, sorry, people watching this, but AI Magic's an internal tool at Answer AI, so you don't get to use it. That's
Maybe I
fair enough.
shouldn't have said that.
That's fine. No, the fact it exists is a known thing. I talked about it on a podcast ages ago. So
Glad I haven't spilled the
now
beans.
you've just increased the mystery.
Ah.
Um, okay, so let's fast forward a little bit. So you actually started working part-time at Answer AI before you even finished high school. Um, and then, we had a bit of a conversation about what next for you, and you felt like MIT was the right place for you to be. So you've been there now for a few months, I guess, and I think you're living there at MIT, right? I'd love to hear like what's your experience been so far, because like again, I'm imagining first year at MIT. There's still not going to be loads of people, either students or teachers you're dealing with, who know enough about AI to be published at NeurIPS. Like, have you found like, yeah, tell me about the experience in general and also whether you've, kind of how you're, whether you're mainly continuing to kind of work with Vlad. And of course, we'll talk shortly about your NSAI work, and how that's what you're learning and experiencing and stuff at MIT.
Yeah, so I think when I first started talking to you about Answer AI, kind of working there, doing a fellowship, I really seriously considered taking a gap year, so that I could, pursue my research projects a little more seriously, have a little more time on my hands. Um, but ultimately, I decided against it just because I feel like MIT is such like I hate to say this, it sounds like so basic, but it's such like a great place to be. I think you're definitely right. Like again, none of my peers, or like not none, but like the majority of my peers aren't really interested in AI. Um, but they're amazing people. I don't know, there's just a very broad variety in like what they're interested in, and they're all super, super passionate about it. And I think like if I think about my future, I don't know, 5, 10 years down the line, I'm not exactly sure where I'll be.
Mm.
Maybe it'll be doing AI research, maybe it'll be entirely something else. And I think having that exposure to people that are interested in other things, people that are the top of their field and whatever that might be is it's very exciting. And so yeah, I guess like I guess that's it. Yeah.
And so at the same time, so you're kind of, got this multi-pronged thing going on where you're working at Answer AI, you're also doing an MIT, I guess, where your new side hustle used to be Fast AI, now it's Answer AI. You've been working with Austin Huang, who is one of the absolute top AI practitioners in the world. He was a project leader at Google, building the retrieval stuff for Google's deep learning models that became Gemini. He's the creator of Gemma.cpp. Yeah, what's it been like, you know, getting involved with working with folks like Austin? What's been surprising about it, or what's the experience been like there?
Yeah, so I think at first I was definitely a little intimidated. The laundry list of cool things Austin has done is just like insane. But I realized like over time, like Austin and like the rest of the crew at Answer AI, they're very down to earth, very happy to like explain concepts, very happy to answer questions. And I think that's like one of the things I've enjoyed the most about working with Austin. So for some context, we put together WebGPU puzzles. Um, and so through that, I had to kind of like,
Let's just take a look
implement.
at that then, shall we?
Yeah, sure.
Um, so here's GPU CPP.answer AI.
Okay.
Okay, so you and Austin built this together,
Yes.
and let's talk a bit about what this is. So this is like, let's go through a few here. Um, these are some pretty hardcore things. Basically, what you're doing here, things like a 1D convolution, a prefix sum. You're asking people to write code, fill in something
Yes.
to what's what is like a fairly complex thing written in hardcore low-level GPU code. Sorry. Um, Kind of, yeah, hardcore low-level GPU code, which if it's taught at university at all, it would be like probably in like a master's program or something like that. This is like it's extremely, extremely, extremely advanced. And you're also doing it in like a brand new framework that Austin invented. So it kind of reminds me a bit of Ada Lovelace in some ways, like, um, she was the first computer programmer, and she was programming a computer that had just been invented. Um, I mean, how do you, yeah, I mean, is that your background? You've got years of hardcore CUDA, GPU, low-level background of programming. Like, how did you implement and contribute to this project?
No, I think my entire GPU programming background was probably like the 3 hours I spent solving Sasha Rush's GPU programming puzzles. And that was really fun for me. But in terms of just like putting this together, I think like learning on the fly again was like a huge thing for me. And also just like knowing that the framework wasn't complete. And so if I had like any questions, that Austin would be more than happy to answer
So
them.
it's nice to have the guy that wrote the framework there to ask questions about the
Exactly.
puzzle. Yeah.
Yeah. But another thing that I kind of just like reminded myself of was that So for a little context, Sasha Rush is, I believe, a professor at Cornell. He wrote these GPU puzzles. You can run them in Colab. But the idea is basically to kind of distill down the ideas behind, this sort of paradigm of like parallel GPU computing, and then have it presented in a very fun, interactive, sort of like puzzle solving way. And so through that, I kind of learned like, hey, like this is how you actually think in parallel, essentially. And so when I was implementing the web GPU version, I kind of reminded myself that like, hey, even though this is like a new framework, things are a little hacky here and there, like the essential idea is the same. And for me, the goal for these puzzles was the same kind of along the lines of the experience I had with Sasha Rush's, kind of just distilling down those really core ideas into something that beginners could digest, anyone could digest, and really have like a fun time with. And so that's kind of like my like overarching philosophy when it came to these puzzles. Um,
Yeah, I mean,
yeah,
I'm just
it was.
thinking it is inspiring though, right? Because I hear so many people say you can't expect to make any progress in a career in AI research or practice without a PhD. And, you know, you are so slow, Sarah, you still don't have a PhD, my goodness. And yet, like many, many, many past AI alumni, I'm not saying past AI is a unique way to do this, but it's a very common way to do this. You've forged a great path. And, to be honest, I did encourage you to consider joining Answer AI full time, at least for a year. Like your strength, your portfolio is strong enough that we're just about the hardest company in the world to get into, and we're offering you a position. So it's definitely works out, you know. I do want to ask though, like a lot of people judge on things other than your pure demonstrated competence. A lot of people will at least implicitly judge based on, the fact that somebody's very young or the fact that somebody's female. And so I'm thinking, for example, my friend Tanishq, who finished high school when he was 10 and he wanted to go to university. And he, him and his family faced a lot of prejudice, and struggled to get somebody to understand that he was ready to go to university. And when he finally found a, you know, um, professor ready to take him on, they were right. He shone at university and he went on to finish a really impressive PhD, so I think he beat you to that one. Although you beat him to a NeurIPS publication, so tough crowd. Um, but it was a struggle. And I'm kind of curious to hear, like, it sounds like maybe, I guess in their case, his family were trying to get him to learn through a really classic, okay, stop going to school, start going to university. By doing it kind of more on your own, online, like, has that mean there's been like less of a struggle for you, or has there been times you've found it a bit challenging to get people to take you seriously based, on your age or gender or anything else?
Well, I think the nice thing about having, Fast AI and Answer AI, kind of my research as my side hustle, is that, it's kind of less of, I guess, like a part of my life as in comparison to maybe what Tanish did. Like he graduated high school when he was 10, which is like an insane thing to do. And I mean, really the only option for him afterwards was like college. I feel like generally like my trajectory and kind of like my main hustle kind of route was very more or less typical. And so not being like I didn't really kind of face not being taken seriously or things like that just because it kind of was more of a side hustle thing for me. And but to be fair, like if it were to be a main hustle, I guess I could definitely see how that might kind of suck. Um I think there are definitely people out there that or like programs out there, especially like the MIT Primes program that tries to kind of help out these like younger students kind of unlock that, I guess, potential.
Yeah, so
But
cool
one
that
thing
like
I
Vlad put
did,
in his time to invest in your success.
yeah, he was telling me he thought like at the beginning when the directors of the program reached out to him and asked if he would help, he was like, this is going to be like a ginormous waste of time. But me and the student that he mentored before me, both published papers. Um, and so that was like kind of eye-opening. I think like I've heard around MIT and just in general, like you do need to have like or like the word on the street is that you need to have a PhD, you need to have some sort of like higher level education in order to do these more like researchy and more like I don't know, like interesting jobs. But I think that that's sort of it's a little odd to me because
Well, I mean, like I think you're getting a bit of a like you're seeing how it is now, right? And what you're saying is true now. Maybe at some points it was a little less true, but like right now, there are a few people in the world who have more experience with modern AI than you with your whatever 5 or 6 years. Like it's it's on the higher end, and for somebody who spent 20 years learning, I don't know, Lisp and Prolog and Bayesian statistics and whatever, they're probably going to take 5 or 6 years to unlearn that enough to be able to start where you were when you were 13. So, like for me, this is like a bit of a superpower we have at Answer AI, is we basically totally ignore academic credentials and entirely focus on like portfolio, you know. Um, and yeah, a lot of the folks that we end up wanting to work with are younger, you know, and often they never went to a fancy educational institution like MIT because they were off forging their own thing. So I think, yeah, I think it is like, I think your experience should become the new norm. It'll probably take decades to get there, you know.
yeah, make the side hustle the main hustle. Yeah.
Um, yeah, I mean, I guess another thing about, you know, being a woman in tech in general, it helps to have people who, can help mentor you and so forth. So it's nice, like we've got Audrey at Answer AI, who was the founding president of PyLadies and probably knows more about how to deal with all that stuff than probably anybody in the world. So,
Yeah, and I think like tying back to the MIT thing, I think another part of the reason why I wanted to come to MIT was there are just so many people interested in tech that are women. And
yeah,
it's definitely hard to find anywhere else. It's,
exactly.
we have to keep it 50-50 for, I guess, whatever's sake. So it's a good high concentration of I think like women that
Yeah.
are
No,
interested.
I mean, it matters. Of course it matters. Absolutely. And it's important to end up somewhere where you're going to do your best work, surrounded by people you can do your best work with. Yeah. So coming back then to your research, um, what's it been like for you seeing, O1 come out, this renewed interest in kind of reasoning traces and reasoning combined with reinforcement learning? Um, yeah, how are you feeling about this research field that you got into a year or two ago, and are you planning to keep pushing on that yourself, or is it like, oh, it's too mainstream now, time to do something else?
No, I think this is definitely very exciting for me. I think like, hey, like I chose the right path. The people at OpenAI are doing it. But I think like in general, there are, along with OpenAI, that I actually don't know what's going on under the hood apart from like Twitter rumors, but there have been kind of like a bunch of papers too. I believe there's one called like Quiet Star, a few more along similar lines that kind of deal with the same problem. And I think this is like one of the one of the bigger questions with large language models is that can we like because large language models they kind of infer things, right? Like um they have this sort of representation of language and therefore sort of like logic and knowledge, and somehow we need to somehow they kind of put those things together in a way that is coherent. um but how do we actually like extract the things that we want, right? So I think that's gonna stay a big question, whether it's reasoning, whether it's truth, whether it's kind of like knowing like what things go with what things. Like I don't know if that was clear, but yeah, I can like rerun that too if you want to
No,
cut
no, it's
through
all
that.
good. Absolutely.
Okay.
Um, yeah, I mean, the reason I asked is um, I sometimes wonder that with myself. I'm like, I kind of like to poke at the areas that no one else is doing, you know? So like if something becomes super popular, like, okay, I'm glad, like even with like ULM fit, that was the first kind of real large language model, or large language model kind of application of that kind. And then suddenly everybody was doing it. And I kind of felt like, "Oh, okay, maybe I don't need to be doing this now because lots of people are doing it. There's something else I could, you know, uncover." I guess that's a tricky thing with research is like, do you want to keep uncovering in the same direction or do you want to explore new directions? Are there other kind of directions of research you've been thinking like, oh, maybe when you're done with this, you'd like to go in this other way?
Well, I mean, just being at Answer, I feel like I've been exposed to sort of a lot of the different types of like research. I did like a few tangential tasks, just kind of like exploring the different projects that were going on. And one of the things that I haven't touched in a long time was kind of creating like an application, like a research buddy sort of type of thing. Um, and it's not as researchy as like my previous projects. Um, but I think like being able to kind of create something with like an end user in mind is something else that I want to definitely pursue during my
And
time
that's
at
kind of
Answer.
our thing, isn't it? Our thing at Answer AI is all about research and development with an end user task and a specific end user in mind.
Exactly. And so kind of being able to still kind of experiment with different ideas, having that sort of researchy aspect, but also, I don't know, working towards a very tangible purpose, would be very cool. So,
So before we wrap up, I guess like um, anybody who's watched to this point of the interview, I'm thinking, they'll be thinking, well, I want to be more like Sarah. I think you're a really inspiring role model for people. And a lot of people are where you were 4 or 5 years ago. They're just starting out, probably feeling pretty intimidated, pretty overwhelmed, and thinking like, well, I can't do this. I need a PhD or, whatever academic who's a family member or something. Like, I guess like what would your advice be to 14-year-old Sarah, if she was feeling, there must have been times you were feeling like, oh, I can't do this, or I don't want to do this, or is this worth doing, or like, am I too weird? Nobody else is doing this. Like, what kind of advice or feedback or thoughts would you pass along to that Sarah?
I would say kind of just to know what you're curious in and know what you're interested in and just go for it. Kind of full send. Um,
I'm
there
glad
are
you said
definitely
that. So like it's about like you actually have to care and enjoy it. Like if you treat it as a grind, you're probably not going to do it, right?
exactly like AI is probably not going to be everyone's cup of tea. But I was fortunate enough to have discovered it quite early on. And I just knew that I was very interested in it. And obviously there were times where, like you said, like things got hard. I wanted to like drop everything.
Yeah. So
But
sometimes you've got to grind it out. You've got to
sometimes
like,
you've got to grind it out. But I think like know the reason why you were interested in it in the first place. I think if you're interested in anything, um, there's got to be something very genuine, something very, I don't know, compelling about it. So just remembering back to the first time um, you were interested in it, and kind of just knowing that like there is an end goal in mind that you'll probably reach if you keep at it. So
well,
yeah,
I'm definitely going to share this story with my 9-year-old daughter who loves coding and she loves math and she loves calculus. And I think she'll find this very inspiring. And I hope that other kids and adults do as well. But I know you're definitely an inspiration to me, Sarah. So thank you so much for this time and for being involved.
thank you so much for having me again.
Okay, bye.
Bye.